range of mode of representation of reactions, how equilibrium constant changes. So it depends on mode of representations of reactions. So it depends on temperature, and it does not depends. It does not depend like initial concentrations of reactants and concentration, that is, you can write change in concentrations of reactants, or you can write pressure, change in pressure or volume, etc. So we are discussing the how the equilibrium constant depends on this and how it does not depends. So we have also solving some problems. So some problems are left. So let's solve that. First, one of the examples is this questions. So what happened here? That PCl is decomposed to PCl3 and Cl2. And what happened? The calculate Kp or Kc if initial A moles of PCl is taken. So at T equal to 0 initially, this A mole is there. So product has not formed. So 0, 0. And T equal to equilibrium. That suppose XH consumed. So if 1 moles XH consumed, then XH2 formed. This is also 1 moles. This is also 1 moles. So XH consumed. So XH formed for PCl3 and Cl2. So they ask calculate the Kp and Kc. So if you calculate the Kc, then what you are studying from law of mass actions, that concentration of product divided by concentration of reactants, that is known as Kc. So concentration, this is T equilibrium. So if you search the concentrations, then divided by volume. Since here volume is not mentioned, so we take as 1 liter. So if 1 liter is taken, so divided by 1 is equal to same. So there is no effect since volume is 1 liter. So concentration of product, that is concentration of product. So let's write PCl3 and Cl2, concentration of product divided by concentration of reactants. So one thing, that Kc does not depend on the initial concentration. So these are the initial concentrations. This is initial concentrations. This is concentrations at equilibrium. So which one we will put? So Kc does not depend on initial concentration. So we will not put this one. So Kc only depend on the concentrations at equilibrium. So Kc will be the concentration which is at equilibrium. So product case X, PCl3 is X, and this is also X, and reactants is A minus X. So this will be X square minus A by X. This, so Kc is X square A minus X. So similarly, if we solve, so Kc we got, Kc is X square A minus X. And also calculate Kp. So for Kp, we should calculate the total number of moles. So total number of moles because Kp, that is partial pressure. Partial pressure, how we are calculating partial pressure of any molecules. Suppose if we say PCl5, then what that molecules, the concentrations of that molecules at equilibrium divided by total moles. So how much there is A minus X divided by total moles. So total number of moles equal to, we will add everything, that is A minus X plus X plus X. So this cancel, that is A plus X. So total number of moles is A plus X into pressure. Similarly, PCl3, that will be how much, X divided by total moles, that is A plus X into pressure. Similarly, PCl2, that is X by A plus X P. So Kp will be, so Kp is partial pressure of product divided by partial pressure of reactants. So that will be partial pressure of Cl and pressure of divided by pressure of PCl5. This is Kp. So product by partial pressure of product divided by partial pressure of reactants. So how much partial pressure of PCl3 is X A plus X P, and PCl2 is X A plus X P, and product is A minus X A plus X P. So so if you cut this, this is cancelled, and one for P, another P is cancelled. So what is left? X A plus X P. This is the left in denominator, but A minus X. So this is left after cancelling. So rearrange it, how, what it will be, that will be the X square, then A plus X take to down, and denominator, that will be A plus X A minus X, and P is there. But that's Kp is equal to X square P A plus X A minus X, because we know that A plus B A minus B, this is equal to A square minus B square. So I can write this Kp equal to X square P, this I can write A square minus X square. So this is for Kp and this is for Kc. Okay, so next problems. What this is, A gas plus B gas going to give C gas plus D gas. AB are mixed in a vessels at temperature T. The initial concentration of A was twice the initial concentrations of B. After the equilibrium is reached, the concentration C was thrice the concentration of B. Then calculate Kc. So what it says, initial concentrations. Initially, the concentrations of A was twice the concentration of B. So suppose we are at 1, then this is twice of B, so this is true. So initially no product has formed, so 0, 0. So T at equilibrium, so what we know, so suppose X is consumed, then this is also 1 molar, this is 1 mole, so 1 here also X will consume. But this is also 1 molar, this is also 1 molar, so X has formed, X has formed. So from 1 mole, if X has consumed, then from 1 moles X has to be produced. So T equal to equilibrium, and but it says that at equilibrium, after equilibrium is reached, concentration of C was thrice the concentration of B. Means what it says that X is thrice of 1 minus concentration of B. Means after equilibrium reach, concentration of C, that is X, was thrice, 3 times the concentration of B. So 1 minus X is the concentration of B, and X is 3 times at equilibrium. This is what it says. So X equal to 3 minus 3X. So from here we can say 4X equal to 3. So X equal to 3 by 4. So Kc, so 2 minus X. So Kc if you write, then for Kc what? Kc is equilibrium constant. So equilibrium constant depend only on the concentrations at equilibrium. So it does not depend on initial concentration. So we will write the concentrations which is at equilibrium, and Kc we know that is product divided by reactants. Product concentration divided by reactant concentration. So product concentrations, that is C D by A B. So C is given X and this is also X. Since here actually this concentrations does not mentions any volume, so we can take it is 1 liter. So divide by 1 is 1. So concentration also same as moles. So we can take this X and A is 2 minus X and B is 1 minus X. So this will become, so X equal to 3 by 4. So put that value 3 by 4 into 3 by 4, here 2 minus 3 by 4, 1 minus 3 by 4. So solve it, how much this will be? 3 by 4, 3 by 4, and this will become how much? That will be 4, that will be 8 by 4 minus this will be 1 by 4. Multiplied, right? So 1 by 4. So cancel it, 4 4 4 4 cancel, that is 1 by 4, 8. So this will be 5 by 4. 4 to the 8, 8 minus 3, that is 5, 5 by 4. So what is the value? 9, everything gone, 5. So this is the Kc. So multiply by both sides, that is 18 divided by 10, that is 1.8. So Kc is equal to 1.8. Next. So this problems again, what he says, H2 gas plus I2 gas is going to give 2Ha. What he says, at initially 3 moles of H2, 3 moles of I2 are kept in a 10 liter container. So 3 moles, 3 moles. So at initially no product H4, and what it says, P equal to equilibrium. So this is 3 minus X, 3 minus X. This is 1 mole, so 1 mole. So from 1 moles X is consumed. So for 2 moles, 2X will pour. Then what they ask, Kc the 8 is given. Kc is given 49. Then find the number of moles of I2. So previously they asked to calculate Kc. Now they given the Kc and asked to calculate the concentrations or moles of the reactants. So how will you solve? So we know that Kc is reactant concentration, product concentration divided by reactant concentrations, that is HI, and coefficients will get power, and H2 I2. So HI, how much it given? 2x square, and how much this? 3 minus x, 3 minus x, and given that Kc is 49, that is 2x square. So this I can write 3 minus x whole square. So this one I can write 7 square equal to 2x 3 minus x whole to the power square, because this is both are square, so I can take common as square and I can cut this. So what I will get? 2x 3 minus x equal to 7, then 2x equal to 21 minus 7x. So this I can write 9x equal to 21. So x equal to 21 by 9. Then how much? 3, 3, 7. So 7 by 3. So just divide it. So x equal to 2.33. Okay, so x value we get. Then they ask that find the number of moles of I2 at equilibrium. So I2 is this. So I2 is this. So they want to ask the value concentrations of I2 at equilibrium. So this one value they want to ask. So in x equal to this, then just put 3 minus x value we know 2.33. So if we solve it, then how much we get? So this will be 300 2.33. So 10 3 is 7, is 960. So 0.67. So 0.6. So this is equal to 0.66. So option C. Next problems. But they ask that SO2 and NO2 gas going to give SO3 and NO gas. The equilibrium constant for this reaction is 16. Again, they given the Kc and they wants to ask the concentrations. Equilibrium concentrations of NO. So at equilibrium, what are the concentrations of NO? So they are asking this concentrations at equilibrium. So I will solve in the next page. That is SO2 gas plus NO2 gas going to give SO3 gas plus NO gas. Yes, SO3 gas plus NO gas, and given that equilibrium constant for this reaction is Kc is 16. If 1 mole of each 4 mole is enclosed in a vessels of 1 liter, find the equilibrium concentrations of NO. So they are giving that at T equal to 0, all the 4 gases has 1 mole, and T equal to equilibrium. So what happened? So from when suppose X is consuming, so here also 1 mole, so here also 1 X will consume, so here product, so X will form. So reactants consumed means product has formed, so here also 1 plus X. This is the moles. And if you write liters, so since volume is given 1 liter, so this also become 1 minus X1. This is the concentration. So something by 1 is same, so we can neglect this. So what will be the Kc? Kc will be the concentration of product divided by concentration of reactants. So concentration of product divided by concentration of reactants. So SO3 it is given. So we are only taking the concentrations at equilibrium. Initial concentrations Kc by equilibrium constant does not depend. That's what we studied, that the dependency of equilibrium constant. It does not depend the initial concentrations. So Kc is, so SO3 how much? Product concentration, that is 1 plus X and 1 plus X. And SO2 is 1 minus X, 1 minus X. So this value they given that it is 16. Okay, so this value given 16. So I can write 1 plus X same, so square. I can write 1 minus X square. So this one I can write 4 square. So what is it? 1 plus X minus X whole square equal to 4 square I can write, and I can cut it. So 1 plus X, 1 minus X equal to 4. So 1 plus X equal to 4, 1 minus X. So this can be 1 plus X, 4 minus 4X, that will be 5X by 3. So X equal to 3 by 5. And if you do that, 3 by 5, so multiply by 2 both sides, 6 by 10, that is equal to 0.6. So X equal to we get 0.6, and it asks to calculate the find the equilibrium concentrations of NO. So it is asking to calculate the concentrations of NO. So this value they are asking at equilibrium. So X we get 0.6. So 1 plus X will become 1.6. So equilibrium concentration of NO is 1.6. Next we study, next topic is degree of dissociation, that we can represent as alpha. So if you define it, then it is the number of moles dissociated, or it is the number of moles dissociated per mole of the reactants at equilibrium. This is important, at equilibrium. So suppose if I say PCl5, this is going to give PCl3 plus Cl2. So what is, suppose initially T equal to 0, this is 2 moles. Now product has formed 0, 0. So T equal to equilibrium, suppose 0.4, this mole is dissociated. So 2 minus 0.4 into how many? 2 moles? 2. So this is known as degree of dissociation. Degree of dissociation, that is the number of moles dissociated per moles of the reactants at equilibrium. Suppose here if it will be the per, then it will be per, again this will be per. So how many moles it, so how many moles it present, from that moles how much it dissociated. So that is called degree of dissociations. So suppose if I say we can write this as from 1 moles how much moles dissociated. So from 1 moles how much mole dissociated? So it means alpha is always less than 1 and greater than equal to 0 or greater than, and yes, if alpha equal to 1 then this is reactions fully completed, that is or irreversible reactions. We will not study in equilibrium. So for irreversible reactions, equilibrium has not achieved. So if alpha equal to 1, that is for irreversible reactions where reactions is fully completed. And alpha equal to 0, then reactions not proceed. So alpha can be greater. So alpha is less than 1 and greater than equal to 0. This is the range of alpha. So if alpha equal to 1, then that is for irreversible reactions, and if alpha equal to 0, then the reactions is not proceed. So for reversible reactions, alpha range can be from 0 to 1. So range of alpha is 0 to 1. And normally we found that like 0.3 to 0.8. This is the normally maximum times we will find that alpha value, or this may be 0.2 like that. So alpha value is very less, that is less than 1. So maximum times we used to neglect the alpha values because it's very less values compared to 1, that is 0.1, sometimes 0.05 like that. So alpha value is to be very less, so sometimes we used to neglect for calculations to easy because its value has not affected. So if I say the percentage of alpha, like if I say suppose alpha is 0.5, then percentage of degree of dissociation, and what, 0.5 into 100, that is 50%. So let's solve some problems with related to degree of dissociations, so that by problems we understand more about of alpha. So one problems we have, that is that suppose N2O4 gas is in equilibrium with 2NO2 gas, and alpha is given 0.25 at 1 atm pressure. The value of Kp is close to. So alpha value is given, and they ask to calculate the Kp. So what, N2O4 gas is equilibrium with 2NO2 gas. 2NO2 gas, and what this is, alpha is 0.2. So T equal to 0 initially. This is suppose 1 mole is there, no moles has product, so product has not formed, and T equal to equilibrium. So from here 1 minus alpha H consumed. So from 1 moles 1 alpha H consumed. So for 2 moles 2 alpha will form. This is the Ostwald loss. So from how many moles how many H consumed, and from how many moles how many H formed. Suppose if this will be 4, then 4 alpha will form. So if it is X, then X alpha will form. So here 2 moles, so 2 alpha will form. Similarly, if this is 5 moles, then 5 minus 5 alpha will consume. So 5 alpha will consume. So that depend on the moles. How many moles the reactants is present. So here 1 moles. So this will be 1 minus 1 alpha, that is alpha. So Kc. So we many times, now let's see volume. Volume has not mentioned, so we take as 1 liter. Oh, sorry, it asks the Kp. Okay, so for Kp, we need to calculate the total number of moles. For Kp, we have to calculate the total number of moles. So total number of moles will be 1 minus alpha plus 2 alpha. That is 1 plus alpha. So Kp will be the partial pressure of product divided by partial pressure of reactants. So for that we have also calculate partial pressure of product. So partial pressure of product will be how much in the concentrations given at equilibrium 2 alpha and total moles total 1 alpha into pressure. Similarly for N2O for partial pressure will be how many moles is there, concentration is there 1 minus alpha total, that is 1 plus and pressure. So Kp is product concentration divided by reactant concentrations, and if coefficient is 2 then that will get power. So NO2 is 2 alpha 1 plus alpha and again so 2, so 2 alpha 1 plus alpha, then reactants 1 minus alpha concentrations. So how can I do? So 1 plus x, so this is 1 plus, this is 1 plus alpha. So this 1 plus alpha cancels. So what is remaining? This p cancel. So remaining 2 alpha, then 2 alpha, 1 plus alpha. This is 2 alpha, and below side denominator 1 minus alpha, and this p is cancelled. So this things has remained. So Kp will equal to, that will become power alpha square, and take this in denominator, then 1 minus x 1 plus x, and p is left. So this one we can write 1 minus x 1 plus x, that is a square minus b square, a plus b, a minus b equal to a square minus b square. So this you can write 4 alpha square 1 minus x square p. So this is the expressions for Kp. So what they ask? What they ask? The value of Kp is close to, okay, and alpha is given 0.25 and pressure is 1 atm. So you get alpha equal to 0.25 and pressure equal to 1 atm. So you just put this value in the Kp expression. So Kp equal to, for alpha value is 0.25, so this one I can write 25 into 10 raised to minus 2. 25, this is equal to 25 by 100, and this one I can write 25 by 10 square. So if I take above, then 10 minus 2. So I can write 4 into alpha is 25 10 raised to minus 2, 2 times 25 into 10 raised to minus 2, and 1 minus alpha, this is alpha, this is alpha. So alpha value again how much? 25 into 10 raised to minus 2, 25 into 10 raised to minus 2. I said that this value will become what, this this 1 minus this will become 25 625 into 10 raised to minus 4. So this will become very less value compared to 1. So this one we can neglect it because alpha itself is a less and alpha square become very less. So it's better to cancel this value because it will not affect our result. So we just put as 1. We cancel it because that become very less values, and if you consider it also that become 1.00. If you subtract, then this will become 0.998 something like that. So it's equal to 1. So that's why we cancel it and just put the 1. So 1 minus x square, just putting 1, we just cancel this value, take a 0. So this is this. So if you calculate this, then 4 into 25 into 25 and take this value down, that will be 10 to the power 2, that is, you can say 100. This is 100. So 4 is 4, 25 by 4, 4 by 4, 4. So this I can cancel. So remaining is 1 by 4 and p is there, and p value is 180. So kp equal to 1 by 4 into 1, that is 1 by 4. So if you do that, then just multiplied by 5, then this will be 5 by 20, and 2 divided by 5, that is much 2.5 by 10, that is 0.25. So kp we get, so kp is equal to 0.25. So that as kp is close to 0.25 atm. Option C. This is part A. And part B, what does? If total pressure change to 0.1 atm, the value of kp and alpha will be. So it says that kp, kc, that is called equilibrium constant. This is equilibrium constant and it does not depend change in pressure by concentrations. It only depends on temperature. If you change temperature, then kp change, or mode of representation, that things depend kp. So kp does not depend on change in pressure or temperature. So here 1 atoms and they changed the pressure to 0.1 atom, so decrease. So what is the value of kp? So kp will not affected. So here 0.25 atoms, so here also 0.25 atom, and they ask the alpha value. The if total pressure changes to 0.1 atom, the value of kp and alpha will be. Okay, so kp is 0.25 atom, it's right, but we don't know the alpha, so we have to calculate the alpha value here. So kp has to be 0.25, so here says 0.30, so it is wrong. So this also can be, this also can be, this can't. So because kp is constant, so this value same has to be kp. So you just calculate the alpha value and you will choose the answer. So